So we've talked a bit about the median and the IQR, which is what we use for skewed distributions. And now I want to take a look at those symmetric distributions. So remember, for a symmetric distribution, we want to use the mean for the center and the standard deviation as our measure of spread. So I want to go over the standard deviation a little bit. And mostly I just want you to listen to this. In the very next slide, you'll be able to fill the table and we'll go back over all of that. So mostly just give this a listen and kind of see if it makes some sense. Let's start with these properties. So you're going to use the standard deviation only when you have a symmetric distribution. So you wouldn't use this with a skewed distribution. It's paired with the mean, so you'd want to do the mean and standard deviation always go together. And what this does is it measures the variation or the spread about the mean. So if the mean is kind of the center of your distribution and all the data is piled really close to it into this super tall mountain, then we would say that your standard deviation is really small. Your data is not spread out. If instead you have a really low-lying hill that kind of spreads out in both directions for a long ways, your standard deviation is going to be really big. So we would say that your data is very spread out. Okay. The values for this, so the standard deviation is always positive. There are a couple times when it could be 0, and that would only happen if your data set had all the same number in it. So if it was 5, 5, 5, 5, 5, 5, a whole set of 5s, then your standard deviation would be 0. There's no variation there. It's all the same. Standard deviation can never be negative. So this is a lot like a distance in physics. We don't measure this in the negative. So standard deviation is always positive or 0, but that's pretty rare. The units of measurement are going to be the same as your original data. So if we were measuring the heights of students in inches, then the standard deviation is also going to be in inches. Right? And here's that warning again. Standard deviation and mean are not resistant to outliers. So if there's an outlier, it's going to change the value of the mean and the standard deviation quite a bit. Okay, and then we do have a formula. We will not calculate this by hand because it's really gnarly. It's this guy here under the square root. And so what you do is you take each data value. So you take the height of somebody and you're going to subtract off the average height and then square that. You add all of those together and you divide by n-1 and take the square root. Now this n-1, you're going to see this again. This is actually known as the degrees of freedom in statistics. So you don't have to worry about that yet. You'll see that again in Unit 5. But just to kind of show you, it kind of pops up in a couple places. All right, so now that we've talked about that, let's get that table filled out. So look at your notes and let me get over to that slide. So we have 3 measures of spread that we're looking at. We have the range, which was from Chapter 1, the IQR, which we looked at earlier, and the standard deviation, which we just did. So the range actually doesn't have a symbol, and it's just the difference between the largest and smallest values. The IQR, the interquartile range, is actually just represented by that word IQR. And what that does is it gives you the center 50% of your data. So it gives you an idea of where that's at. And then the standard deviations. The standard deviation, there are 2 different symbols for this one. And it's going to depend on where you're getting your data from. So if we were looking at the height of everybody in the state of Colorado, and we were able to find the population standard deviation. So, sorry, that says mean, that should say standard deviation. Then you're going to use the Greek letter sigma. So sigma is an O with a little curly Q on the top. If instead I'd gotten a sample of 800 people from the state of Colorado and I found their average height of that sample, then I would use the letter S for that. All right, the values for all of these, they all have to be greater than or equal to 0. So they're all positive. They could be 0, but that's pretty rare. And then the units of measurement are going to stay the same as well. So it's going to be whatever the original data is in. So again, if we're doing heights of people in inches, then the range, the IQR, and the standard deviation are also all going to be in that inches. And then our notes. So the range is always going to be greater than or equal to the IQR or standard deviation. So it's always going to be the biggest possible thing. And in the next video, we'll actually look at a picture of that and see that. And then the IQR shows you how consistent that center part of your data is. And you're hoping that that's actually pretty consistent in most cases, but that's what that's giving you a clue to.